So, I hope everybody is still awake after lunch, and we'll dive a bit into the security side. Let's see how much fun that can be for everybody. So, who has done something like this in the past? That you wrote some Ansible script and that checked, is a port open or something around security? Who has done something like this? Was this a good idea? Maybe, nobody knows for sure. So I have definitely done things like this. So here in Ansible, I was just basically at the end checking that specific ports are open or not open. So I wanted to make sure that my deployment was in a reasonable state at the end of doing things. And it kind of worked, but it also kind of didn't work. And we'll want to dive a bit into why this kind of doesn't always work. So for a long time, then you're in this state where you're saying, like, this is fine, and you may know that maybe not everything is fine, but we'll say everything is fine for now. And then, come on, clicker. The thing that we want to do is, or why this is maybe not so fine, is we want to decouple the change from the policy how we apply them. So we basically want to have a policy that checks my application without the deployment step, because it's very easy to kind of like miss something when you have everything bundled together. It's also not so easy to continuously run it, because what you really want to do is you want to run these checks around security constantly. So if you only do it every time you deploy, if somebody in the meantime checks or changes something or something crashes like the firewall process, there is no way to figuring out that you're not in a state that you expect. And because nobody would do that, but every now and then somewhere someone SSHs into a box and changes something to check something, and you're sure you will revert everything and you will close down all the ports and stop all the things that you have started. Unfortunately, that doesn't always happen, and then you're stuck with that problem that while your policies or when you deploy, it would be checked, but in the meantime, you don't check, and then bad stuff happens in between. And you, of course, want to manage all of this as code, because we want to codify all of that, have a record of when changed what, and how to run with that. And you, of course, want to gain the insights into the current policy state. Who has a system where they know how security policies are running and what is in what state right now? That is very few. And while it sounds like a boring problem, it can actually be very helpful, because every now and then you have a security audit, and then you make huge lists and documents of like what is in what state and what have you managed and not managed. And the idea really is that rather than creating those documents manually at some point, you have those policies codified all the time. You can continuously run them, and you know in what state your system is and where you're at today, even without an audit. So why is all of that important? Because security incidents basically come in 3 different levels. It's the for your information, the WTF, and the oh my god. And especially the oh my god is the state you don't want to reach for security incidents. And yes, I know there are CVS scores with a score from 0 to 10, and those are the official ones, but I think that these are much more helpful. That it really tells you how to think about security issues and how bad they might be. And we want to avoid the very bad stuff with them. So the levels from worst to least bad are pretty much like, the worst one is you know or you learn from something from the press or your users. It's somebody has stolen all your data and is now abusing your users, or the press is talking poorly about you. What's also not great is if you are learning from that because the attacker sends you a ransomware note and they ask for money, which is not great, but at least it's not as publicly humiliating. It's just expensive. Or what could also happen is that, come on, clicker. You could learn it from your cloud provider's bill. So it's just very expensive. Ideally, you figure it out yourself after something happened, but you figure it out yourself and you can stop it pretty early on. And the best case would be that you find out that something is in a bad state before any harm can happen. And that is kind of like what this talk wants to show, that you have policies and you apply the policies, so even when you try to deploy something that might be out of order, you can catch it very early on before anybody else gets to it and can exploit that. So that's really what we want to have. We want to find stuff before harm can be done. And by the way, the other thing is tribal knowledge, that Sam somewhere over there knows how stuff works, is not a security policy, or is not how security should work. It needs to be encoded somewhere in code that can continuously run, and it shouldn't be just in one person's head, because they could forget, they could leave the company, they could be on vacation, and then your security is gone. That's why you want to really have that codified somewhere else. So all of this should lead us to a state where we don't have the problem that everything is on fire and everything is horrible. That's the state we don't want to have at the end of the day. So obviously, there is no silver bullet to all of this. While there are vendors, and I work for a vendor too, but vendors will always try to sell you the silver bullet. But reality, unfortunately, does not have these silver bullets. It's like security, like many other things, is like many different layers and many components that play together. And tools are, of course, an important part of that. But there is not one thing that you buy and turn on, and then you have security. Unfortunately, it doesn't work like that. The good thing is, this also keeps all of us employed. Because you can't just buy something and then your job is done, but your job just builds on those tools that you can use. So it's a good and a bad thing at the same time. And this leads us to OPA, the Open Policy Agent, which is one of the graduate projects of CNCF. It started quite a while ago in 2016, and it's actually pretty widely used, especially from the bigger companies. So Netflix, Cloudflare, and others are using that. Is anybody using OPA already here? Okay, that's like 8 or 9 people. Okay, cool. How is that working? Well? Not so well? Okay, I see this gesture, so we'll see what is good and bad about OPA and what it can actually do. So CNCF graduate projects, there are quite a few at this time. I think every time I have this presentation, I need to update this slide. The last time, I think 2 months ago when I did this, there were 22, now there are 24 graduate projects, and some are very well known and widely used, like, I don't know, Prometheus maybe, or Kubernetes itself. And then there are others that are a bit more obscure. And I guess OPA is kind of like in the middle of those projects. Not widely enough known, but also not super obscure. So let's see what this is doing. So the idea of OPA is that you have all of these things that you want to secure. And most of them have an API that you can talk to. Or you can somehow query it and figure out how things are going. And OPA will work both within your application, but also for your infrastructure. So it works well for your data services, for your APIs, for your containers or Kubernetes clusters, but it will also work within your applications itself. And I'll show you both a bit as we go along. The general architecture of OPA is quite simple. So your service, or a service, is reaching out to query for a policy, and it talks to OPA, which is then a binary or something on a port that you can talk to. And you have the policies, which are written in Rego, which is a custom language, and it can also query additional data. And then it will basically give an answer back about the policy decision. So the policy decision comes in, and it will give, it's not just a yes or no that will come back, but it can give back any data. Oftentimes, you will give back allow true or deny true or something like this, but it could be more complex. Writing rules is done in Rego. Rego is like close to JavaScript, and I think that the pitch is that it's easy to turn natural language into Rego rules, but depending on where you are, saying something is close to JavaScript might be either great or might be horrible. It's normally one of the two. I assume with this audience, JavaScript will be a bit less popular, but we'll see how much you like the Rego syntax. And then you can query data to to see how it's going. So the hello world of Opera is pretty much this. We have this policy. So we say if something is a get, and if you have the parameters my data and employee, and the user matches on the employee. So this is the user that does the get, and they basically want to access their own data or their home directory, basically. Then return true. This is the policy. And then the input, what happens is, a get happens, the path to my data is Philip, and the user that requests the data is Philip, so these two match, and then we will return true. So I can access my home directory or my data. Another user cannot access my data. That's the general rule of what we are encoding here. You can also make this slightly more complicated, that you say by default, the answer is false, and only if this condition here matches, then you return true. And in this example, the answer would obviously be false, because Peter is trying to access Philip's data directory, and that is not allowed with our policy. And that is the simplest form of what you can encode in Opera. You can also add data. That's what I've shown you before in the graphic, that you can add some data here. And what we're adding here is that we have managers. And the managers can basically access the data of their employees. So Philip can access the data of David, and Matt can access the data of Philip. And then we express that here with that data structure, data manager of, that basically the manager of is in that chain of employees, and then you can also access that data. So those are the three components. You have the policy, you have an input, and optionally, you have that additional data if you need to have like any additional structure or information around it that you might need. And that's your Opera rules. Very simple, until it gets complicated. But we'll get to that part. So these were like the Hello World examples, and these are still very simple, but this is maybe a bit closer to the infrastructure side that you're used to. So for example, in here, we're working with Kubernetes, and what we want to do is we want to say that Docker image is coming from a specific registry. So at Elastic, we have our own Docker registry, and we are saying like an image must come from this registry. Otherwise, it will fail, and the error message will be the image, whatever image you have here, comes from an untrusted registry. So this is how you could enforce something like the Docker image needs to come from your own registry, and somebody needs to have pushed it there. You cannot just pull in random images from whatever other registries out there. To have a bit more of a Kubernetes example. You can also have the same thing in your application, where you basically have, again, default allow false. Now somebody wants to write, I think somebody has a pet, so you can only change things for your own pets. So the pet ID and the user needs to be the owner of the pet, and only then can you change your pet's information. And you might not want to encode it within your application, because then it's mixed in with all the other code, and like one big change might make it easy to overlook a policy like that. But the policy is a separate thing running on the side, and your application is basically querying that policy to figure out if a specific action is allowed or denied. That's for the application side, or you could continuously run your rules against something like your infrastructure to check if it is in the right state. So you have these two modes, within the application or against infrastructure. And I'll have more examples for both of them. One hands-on example is here from DoorDash, and they have, when they file a pull request for their Terraform scripts, they have a full evaluation if that Terraform change would break any of their security assumptions or models. And it looks like this. You file a pull request, you push it to GitHub, the pull request is opened and tested. They have their own testing and deployment tool called Atlantis. So what Atlantis then does is it fetches the Opera policy from S3. It will run it against the Open Policy agent, and that will tell you that this policy that you have checked was okay or was not okay. Based on that, you will add a comment in the pull request, and you will say, well, this change follows all the security best practices that we have encoded or not. If it's okay, then you can push out the change. If not, you will need to go back and fix your pull request. But the thing here is, you never push a change with Terraform out that might add any settings that are not okay in your policies. So you never deploy anything that breaks your security model. And that's the entire idea here. If you want to get started and try out Rego and Oppa, there is the playground, and I'll just very quickly show you the playground. I'll also reload the page because this one, whenever you have that window open for like 15 minutes or so, it breaks in a weird way. So I always try to reload that page. Hopefully it actually reloads now. Good. Let's do one example. Let's say this one here for Kubernetes. So what we have here is, this is the rule, and we'll keep the rule in this case, but we have an input. The input does not conform to the rule. We'll run it, we'll see that it breaks, and then we'll try to fix the input that it actually conforms to the rule. So let's see how that goes. We have a rule here, and the rule is around labels in your Kubernetes. So this is querying the Kubernetes API, and it's saying that you need to have a label that is called cost center, and if not, it will fail the current deployment. So the idea is that every pod that is running in your environment needs to have a cost center label so you can attribute cost. So it's not just about figuring out security, but just enforcing policies in general. When I run this here, and this should run, okay. Okay. You get this error message when something is wrong in your browser. Do a hard reload, and then it will look different. Let me try that again. We'll switch to the right demo. And I blame JavaScript on this one. So when you evaluate this one, now it's correct, because now it tells you every resource must have a cost center label. So far, so clear. If we look at these checks here, what do I need to change to make this rule conform to what we're trying to do? So we have object metadata labels cost center. So we have here object metadata. We'll add some labels. Let's just, to keep it simple, make this an object. And then we'll have a cost center. And then the cost center, I'll just call this foo for now. So here it makes sure it has the label. This one will pass now. And the second one, it has like there's a format that every cost center label needs to follow. This one should fail now. Oh, come on. This is because nobody warned me. This was not good, Jason. This is not what should happen. This one is sometimes a little finicky. Give me a second. We'll just do another reload here. Most of the time it works. So this one here, this is the right place where we need to put this. When we evaluate this, yeah. Now the error is correct. Cost center must start with CC code. Mine starts with foo, so if I make this cost center code and then foo, then our rule will finally work. Maybe. Come on, demo. So now you have no reasons to deny this rule. So this one works. And depending on your browser and internet connection, the playground will work a bit better or not. Every now and then it's a bit finicky. Don't get surprised by that. But you can explore how things are working here. So we have our rules. We run them against the input. You could optionally provide that additional data if you need it. And then you have that evaluation or output of how your rule worked. So far, so good. For deployments, you have a couple of options how to deploy this. You could either, if your program is written in Go, you can just add a Go library. This is the example here. So your application is written in Go. You have the Oppa library in Go, and you just build them into one binary. You could also, within one pod, have the Opera container, and then basically the application checks this one. You could also have it as a separate pod on the node, so maybe this is a daemon set, and you can check it against this one here. What is not recommended is to run it on a different node, especially when your application for every request checks Opera if an action should be allowed. This one just adds too much latency across the cluster that you probably don't want to have that. So you normally want to have Opera co-located if your application constantly checks against it. This is for the application side, not for the infrastructure. For the infrastructure, we'll get to that in a moment. So since I work for Elastic, why does Elastic care about all of this, or why have we looked into this so much? So why we care is, first, there are filters how to check, for example, Elasticsearch queries with Opera, which, again, might be more of a hello world or demo, but it's actually quite fun to see. So what we have here is, we have in the Open Policy Agent repository, there's a contrib project where this is in, and we have basically written data filter rules if you query Elasticsearch to check with Opera if this is allowed or not. And this full thing you can run, but I'll jump straight to the conditions, if my internet makes it. So what we have here is somebody tries to read some data, and the condition is that the author and the user that are accessing the data need to match. So for example, the user that wrote the data needs to be the same that is reading back the data here. Or if you have an admin, then the admin needs to have a specific clearance to actually read all the data. So there are some examples here how you could express which users are allowed to read which data from your Elasticsearch cluster in Opera rules, if you want to encode it like that, just as one example. And this is maybe more of a hello world and interesting to see, but we can make this, especially from an infrastructure side, we can make this a bit more interesting still. You often want to check your infrastructure and see how that one is working or in what state your infrastructure is in. And there is the CIS, the Center for Internet Security, and that has a lot of different rule sets where it encodes how secure infrastructure should look like. So they have, I think, 100+ configurations where they generally say this is how, for example, Kubernetes should be configured, or many other things. Not sure if anybody knows these or uses these. Is anybody using these already? Okay, again, 4 or 5 hands. So they basically give you a framework of what to check and how things should be configured and what will be considered secure or not secure. And you can then follow these. And what we have then done out of these is we brought that into the Elastic Stack to make that automated, and you can run that just against your Kubernetes infrastructure. And what we have done here is, first off, we have written a component that can check that. It's called CloudBeat. It's a public repository, and it basically can run Opera rules for you against some endpoint. And we also have encoded these cloud security posture management, so these rules from CIS, we have encoded them in Rego policies. So basically, the standards for, or the best practices for different cloud providers or Kubernetes infrastructure have been encoded in Rego rules, and we can continuously run that against your infrastructure to see how that is working out. And just to give you a quick idea how that actually looks like. So here, I'm running the Kubernetes rules against the Kubernetes cluster that is obviously not configured perfectly, and it will show you, like, out of all the rules that are in the standard, you conform with 86%. So the remaining 14% are 52 rules that are currently failing, and it will give you a list like for the API server or the kubelet or the controller manager. These are the rules that are failing, and I'll just show you 1 or 2 quick examples how these look like, if my internet manages. So what you have here is, one of the rules is, for example, minimize the admission of containers with the net raw capability. So this is a capability that you might not or might want to use relatively sparingly, and you can see it ties back to the CIS rules in the Kubernetes section. It shows you when it was evaluated, so we just ran this earlier today. It also gives you the remediation. It tells you how you can actually fix those rules and what steps need to be taken to avoid the problem. And if you want to, you can also look at the problem, and like here, we have a list of like, these are the UIDs which with that capability that have been running. So you can actually backtrace what is failing and how to fix each one of these. I don't know, let's see, maybe we have another one that makes sense. Okay, you don't want to share the host network namespace. And again, it gives you the full set of rules of what you need to change to avoid that, and maybe the evidence. Okay, the evidence for this one, okay, it has host network true in the spec, and this is the thing you want to avoid here. And going back, the same applies to all the different areas that it can check here. So for example, for the API server, if my internet manages on the API server, you have, I don't know, somebody was profiling a pod, added profiling on the API server. Maybe that's not what you want to run in production, but on production actually. So again, it tells you what are the settings that you need to change to actually disable profiling, and it can also figure out like, it has a list of all the process arguments of our Kubernetes cluster, and it will tell you, well, these are what we expect or what we don't expect, etc. So you have that for all of the different areas. Maybe, I don't know, I'll show you one last example for the kubelet. But in the end, this will just check all the states in your cluster and then let you know what you need to change or don't change. Okay, you have protect kernel default argument is set to true, or should be set to true, and it is not, and this is how you could change that, and the evidence again is done here, how the process arguments were configured. So all of this makes it pretty simple to check for your rules. By the way, one question that I get quite frequently is from people who say like, well, we turn this on, and it shouts in our face, and we have 500 error messages. Do I need to fix all of those 500 error messages right away? No, you can selectively disable which rules you actually want to run or don't want to run, because the standard problem of any security scanner, as we all know, is you turn them on, they complain about everything, and in the end, you don't fix anything, because it's just too much stuff. Cool. So we have seen that. Some things that are interesting about Rego that we have learned over time is every now and then you want to debug something, and it feels a bit like Rick and Morty, where you go in and you want to debug something in Rego, and then this is the way how you come out again. It's not that you will always fail to actually make progress. It's just sometimes a harder journey than you were expecting at the start. And I'll have one or two examples here. So, for example, we wanted to improve the evaluation performance of some rules, and we managed, and we made it 3 times faster, actually. It was just a very convoluted way of doing that. So the colleagues have been gathering some best practices and made good progress internally, but the process is often not fun. So if you run into that problem, you're not alone. That seems to be a more common thing in Rego. So to wrap up and have some time for questions at the end. I hope I made it kind of clear why you might not want to have all the security policies in your application or have it encoded there, because it's very easy to overlook or accidentally change things, especially when you have a 1,000-line pull request, which of course nobody would do. It's very easy to overlook that one change that changes permission in a bad way. So you really want to have your security rules somewhere external, and you can audit them explicitly and make sure that you don't break any security models. Next up, you probably don't want to have this in change management like Ansible, for example. It's a nice first step, and it's what I have done years ago, and it kind of worked. But it only kind of works because it only runs when you actually run through your change management. And if somebody SSHs into the box and changes in between, you will probably only catch that the next time you deploy. Or your rules don't cover that case, and then you will never catch that. So you, again, want to encode that explicitly. OPA is probably the most widely used ways how to encode things or security policies in your applications. So it's great. The obvious question that always comes after that then is, why not Opera? And the number one reason why people say they don't want to use Opera is Rego. Rego is really the showstopper of Opera for many people. Maybe because it's close to JavaScript or just because it behaves differently than what you would expect. The second reason for alternatives is there are more limited or simpler ways to do things. Opera is covering a lot of ground, but because of that, also quite complicated. So there are some other solutions that might make your life easier. And why Opera can be tricky, I've recently seen this blog post that I thought was a very good illustration. So they wrote the blog post, and it's a 10-minute read how to express an OR in Rego, which sounds a little silly when you think about it, and the blog post then explains that there are many different, so there is no native way to write an OR in Rego, but there are many different ways to get around that. But you need all of these workarounds. So that is kind of the path you're on once you start with Rego, that writing some things you think should be simple are actually quite complicated. That's kind of the warning around it. And also, talking to the people on our team who actually implemented all the Rego rules for Kubernetes and AWS and GCP and Azure, I think the writing experience, especially at first, can be pretty challenging, and some of the feedback was not so great at first. People get used to it, but it's definitely a relatively steep learning curve. That's just a word of caution before you dive headfirst into Rego and get frustrated, that it can have some sharp edges around it. And that's it in general. Do you have any questions? And I think Ricardo will come out with some questions for us in a moment. Hopefully.
Sorry, that was a bit abrupt, so I didn't expect you to finish straight away. First of all, thank you for applause. There is a number of them. It's not my main topic, so you probably can help me digest them. They're asking if security posture works with any CIS benchmark, and if it's flexible enough to use it with GCP, AWS.
So we have implemented it, if I'm not mistaken, by now for AWS, GCP, Azure, and Kubernetes. So we have, in Elastic Stack, those 4 systems are implemented. Other stuff, not yet. And you also cannot bring your own custom rules to the Elastic Stack, at least not yet. So you're only stuck on the 3 main cloud providers plus Kubernetes. Those are the options that you have.
OK. They're asking if there is any way to test the OPA policies, any testing framework kind of thing. Maybe it's complex to do such a thing, but...
So I mean, there is like you can provide the input, the Rego rule, and then you can test it against an output. So in that regard, yes. But I think the main challenge that you normally have is that something in an API changes. So I think you often want to have these integration tests to make sure that it actually works as expected against the actual system. Yeah, you can test the rule in isolation, but that might not actually give you as much as you think it would or that you might expect. So I'm a bit cautious around that one to say, like, there's a great solution for testing that. I think you really want to test it on the actual system. Mm-hmm. Also, if AWS changes any API or it adds any fields that you don't expect, all your static tests are not going to do much for you.
And what about the performance overhead of having the agent? How much is it, more or less?
The Opera?
Yeah.
So it's a Go binary. So in our experience, if you have a lot of rules, let's say hundreds, it can take some time and you can make them faster. But since it's written in Go, it's not as heavy as you might expect. So while we had that example about making things faster, and my laptop is gone, so I cannot show you anymore. So the example that I've shown you was, I don't know, it went down by very few seconds, though we had hundreds of rules, and it was 3 times faster. But it's not like this will take hours to run. So generally, those are reasonably fast to execute.
And they're asking if there's any mechanism to support dynamic data lookup in the rules.
So first, there is data and that there are regular rules, so that the lookup needs to be in the data. But yeah, I don't know exactly how flexible it is, but yeah, since you have the in-memory data, I think you can inject new things as needed. But that's why you decouple the rule and the data. So the rules are the static ones, but if you need to load additional data, then you can have that extra data on top to supplement your rules. So you can combine those.
And I think that was mostly it. So thank you very much.
Yeah, cool. Yeah. Great. If you...
Hold on.
Don't worry.